Hi everybody, welcome back. Today we're going to start looking at comparing tables, equations, and graphs and deciding whether they are linear, quadratic, or exponential. Let's first start talking about the differences between the equations. If we think about our linear equation, those ones are typically in the format of y is equal to mx plus b. In this case, x does not have an exponent other than 1. So for linear, it's going to be a straight line. For quadratic, those are the ones where we had 2 as an exponent. So for example, you would have had something like y is equal to ax squared plus bx plus c. That is the general form of it. Our highest exponent in this case is a 2. And then our third and final type of equation that we've talked about this school year is exponential. And this is where x is the exponent. So you might have something like y is equal to a times b raised to the x power. So those are the general forms of the equations. It's always easier to think of it in how we actually see it. So for linear, you might see something like y is equal to 1 over 4x plus 7. For quadratic, a good example would be y is equal to a negative 2x squared plus 5x minus 1. And for exponential, you may see something like y is equal to 3 times 1/2 raised to the x power plus 2. So it's really good to be able to know and see the differences between them. I'm going to go ahead and circle it right now. With the linear, we have just an x. With the quadratic, our highest exponent is an x squared. And with our exponential, x is our exponent. So let's go ahead and look at some examples now. This chart below contains tables, graphs, and equations. We want to identify the type of function represented as linear, exponential, or none, or quadratic. So if we look at the table here, we can use our graph to identify what table values go there. So at -2, when x is -2, my y value is 0. When x is -1, my y value is 2. When x is 0, my y value is 4. And when x is 1, my y value is 6. If we look at my table here, these numbers are all going up by adding 2. It's a straight line, and we see that it's in the form of y equals mx plus b. So this equation right here, no matter what type of representation we have here, is what we call linear. Let's go ahead and look at another one. So right away, we see that this is an upside down U, an upside down parabola. If we look at our table, let's see what kind of trends happen. -2, get a different marker so we can see it. At -2, the value is -4. At -1, the value of y is -1. 0 is 0. At 1, it's -1 again. And just really to see this completely, I'm also going to add a 2 to our table. At 2, it is 4. So do you guys see how it's symmetrical? If we kind of divide our table in half, with 0 being my middle point, everything is symmetrical. That's a good clue that we're talking about something that is quadratic. The other thing to notice is that we have an x squared. So y is equal to ax squared plus bx plus c. It's in that form because we have an x squared, we have an upside down parabola graph, and we see that our table is symmetrical. This is what we would call quadratic. Okay, let's go ahead and look at the next page. At this next table right here, notice we have a table of values. We don't have a graph at all. So what we could do is look at our table of values and see if we see a pattern. How am I getting from 1 to 2, 2 to 4, 4 to 8? What's the pattern that's happening? Good, I'm timesing every single one by 2. So if we go ahead and graph this out and see what it looks like, we have 0, 1, we have 1, 2, we have 2, 4, and then we have 3, 8. So it's definitely not looking like a straight line. It appears to be doing this kind of motion. Because it's doing that one that has a tail, we're going to call this one exponential. A big key here is that we're multiplying every single time in our table. So now if we look at our graph that we have here for the next problem, you see that this is the exponential graph. You also see that our equation has x as an exponent. So those are both ways that we're going to see exponential represented. If we work backwards and see what this looks like in our table, 0 is 4, 1 is 5, 2 is 7, and we can't actually see what 3 is, but we see that it appears to have no pattern in our numbers here. If we substitute 3 into our equation, we would have 2 raised to the third power plus 3. So 2 times 2 times 2 is 8, plus 3 more is 11. So our point would be like way up here somewhere. But again, if we look at our numbers, 4, 5, 7, there's no real pattern that we can see right away. It's not anything symmetrical. It's not being added or subtracted. So this one definitely is an exponential equation. Okay, so let's look at one more problem here. So this one, there is no graph. There is no chart given. It's just the equation. Because it's in the form of y equals mx plus b, we know right away that it's going to be linear. If we graph it using the slope and y-intercept, we would begin at 2. My slope is -3/4, so I go down 3, right 1, 2, 3, 4. Down 3, right 1, 2, 3, 4. The opposite of down and to the right is up and to the left. And do it one more time. And we have our nice straight line. If we look at our table values for that, let's see here, 0 was 2, 1, we can't exactly see what 1 was, 2 we can't exactly see what it is, but 3 we can definitely see is what? Yep, it looks like it would be 0, but it's actually slightly off from there. So our table, we can't really get a good idea of what this looks like. However, we can see that it's a straight line and that it definitely is linear. So I hope this helps you understand the differences. Again, key things you want to look for to kind of summarize everything is for linear equations. So if you're going to call something linear, it would be a straight line. If you're looking at the table would have y values. That change by adding or subtracting the same number. And finally, your equation would be in the form of y equals mx plus b. Quadratic equations they would have a parabola-shaped graph. So it's either going to be a U or an upside down U. The table would be symmetrical. Or if you're looking at the equation, it would have an x squared in equation. Finally, if you had an exponential function, these ones have a tail. The graph has a tail. And what we mean by that, it's going to be something that starts low and gets high really fast, or starts high and gets low really fast. So there's some kind of tail. If we're looking at the table, you would multiply to get the same number, to get the next y value. Or you may see no obvious pattern. And then finally, in my equation, it's going to be y is equal to a times b to the x power. The way that I like to remember it is x is the exponent. Okay, so make sure you copy those little key ideas down into your notes. If you have that, you definitely should be successful on today's homework assignment. As always, if you have any questions at all regarding anything presented, feel free to reach out to your teacher. I hope you all have a great day. Thanks, and bye-bye.